Okay, so we're going to go ahead and start on the next page, which I think that my numbering system may be off of yours a little bit, as I've heard from, I guess there was a flaw in some numbering, but I believe we're starting on page 6, a little one on trig. So hopefully this is going to work out okay, even though my numbers are a little different than yours. But here we go. So I believe I'm at problem 27, although you might be at problem 28 or 29. I'm not exactly sure, but it's the same questions. There's just a small flaw. So anyway, let's keep moving on. This one right here does not involve any hypotenuse. So we're looking at a tangent being opposite over adjacent. Again, one of the things that I mentioned in the previous video is I know that bigger angles are opposite bigger sides. So if this is 90, these two angles right here have to be add up to 90 as well. And I know that if I've done this right, this angle is going to have to be larger than that one. So it's going to have to be bigger than 45 degrees. You have to think about that one a little bit as to why. Because if we took 45 and 90 and cut it in half, you get 45. So 59 sounds plausible to me. 59.2 degrees. And then this last one is kind of a silly question in a way because you have any option that you want. So I'm going to stick with the tangent because that's the one I just did, but you'll notice if I did an inverse tangent of 60 over 11, remember to find angles, you use inverses. I got 79.6 degrees, but if somebody else said, well, I wanted to use a cosine, well, let's see. The inverse cosine of 11 over 61 is exactly the same number. So you'll notice you had flexibility to do this problem in any variety of ways that you wanted. Okay, so for problem 29, we're just gonna, which again might be problem 30 for you, but we're just gonna look at a variety of ratios. So remember, our magic value, our magic statement is SOHCAHTOA. So the sine standing at angle A is opposite over hypotenuse, so that is A over C, whereas the sine from angle B would be opposite over hypotenuse. So similar stories. Now, as it turns out, the cosine is adjacent over hypotenuse. That's B over C. And one thing that you're going to notice as you go through the math on these problems, every single time you take the sine of one angle, it is going to be the same as the cosine of that other acute angle. And then the tangent of A is A over B, and you'll notice that this one is the reciprocal of that because what is opposite one is adjacent to the other. And since those are the only two values you're using, it becomes a simple reciprocal. Okay, now coming down here into my problem 30, which might be your 31, I think. If this is a 45, 45, 90, since these two angles are the same, that's going to mean the sides that are across from them are going to be the same as well. And then this is just one of those things you have to remember about 45, 45, 90s, that every single time you have a 45, 45, 90, whatever these two sides are, this one is going to be the same thing times a root 2, which means to go backwards, we're going to divide by root 2. And of course, 6 roots of 2 divided by root 2 is just going to be 6. Now, the kind of question that we like to give you in our work that we did in class is, what if I gave you something like 14? Well, this would be 14 over root 2. And then we went over in class how you'd multiply the top and bottom by root 2, and that would give me 7 roots of 2 and 7 roots of 2. And I know it's not great to put extra problems in there, but it hit me that we probably should have something like that there. So 31, it's a little special right triangle story that we want to look at, and that is in 30, 60, 90 stories. Whenever you have a 30, 60, 90, whatever your shorter side is, and the hypotenuse is twice that big. So notice if this is 22, then that's going to make this side 11. And then whatever the short side is, you would multiply that short side by root 3, and that would get you the long side. Now, we didn't have the harder problem here, but we do have it here. So what I need to do is I need to see, to go this way, multiply by root 3. So to go backwards, I have to divide. But unfortunately, that's a problem we're not supposed to have roots in the bottom. So we're going to multiply the top and bottom by root 3. So I got 7 roots of 3, and of course, root 3 times root 3. You could call that root 9, but let's face it, that's 3. So this is 7 roots of 3 over 3. And that means the hypotenuse is twice as big. So if this is 7 of something, then this would be 14 of those same things. So 14 roots of 3 over 3 would be my final answer, okay? That doesn't look like a very good 14. Let me fix that. All right. Let's see if we got enough time to get to the next page down. Okay, we're going to get into some factoring, which I think I'm going to actually pause there. I think I'm going to stop because that one's a little longer. Okay, but we're going to go ahead and stop there. So I'll talk to you later. Bye-bye.